Okay, we are live. There it is. I welcome you all to the first ever FIP Hangout session. In a moment, I'm going to introduce you to the speaker. But before that, my name is Kirti Vasan. I am the creator and editor of FIP. And my role today is merely to redirect your questions to the rocket scientist. Her name is Marielle. With that, I introduce you to Marielle. You can go ahead.
Hi, my name is Marielle. I am a recent graduate of the University of Florida in aerospace engineering. I have done some past internships and more so in the aeronautical field, but my undergrad was spent doing research in space debris, in particular a project called DebrisSat, where we launched a projectile at a Mach satellite on Earth to match speeds in orbit. So if you want to hear any of the things I'm going to briefly talk about right now, you could just say talk more about this, but I'll get to your questions later. As far as some things I've done in my undergrad, towards the beginning was part of Society of Women Engineers. I then did Tau Beta Pi and then Astronomy and Astrophysics Society. I've done multiple classes in astrophysics, even though I did not major or minor in that. Currently, I have just been accepted to the PhD program at the University of Colorado Boulder. In particular, I will be working on studying how space debris moves, because the focus will be astrodynamics, which is the study of motion in space. I will be studying how we could apply things we've learned about how asteroids move towards how man-made objects that are weirdly shaped move in space. As I said, I started Miss Aerospace, my blogging website, to sort of create a dialogue as a friend instead of an educator. So I like to keep my conversations casual, so you can ask me questions in a very casual sense, and I definitely will be responding very casually as if a friend was telling you this rather than a teacher. But I do have a substantial background in the field, and I will be able to answer any questions you guys have. With that said, we can start the questions.
Perfect. We're waiting for a few minutes for the questions to come in, or there have already been a couple of questions that have been asked, so we'll go ahead with that. So we'll wait for a few minutes for the questions to pour in. Okay, we'll continue to wait for questions. We have some starting points, so we will switch over to the questions that have been already asked by the followers. First things, is rocket science really actually rocket science? Is it that hard? How hard is it to study rocket sciences?
I think it's very easy to be elitist as a rocket scientist, to be like, oh, I'm a rocket scientist, I've achieved the unattainable. The truth is, it's hard and it requires a lot of work, but that doesn't mean that not anyone, only a select few people could do it. It just matters how much dedication you want to put into it, how much work you want to put into it. My undergrad was spent working a lot, studying a lot during, while friends of mine were out having fun, and that's fine. I'm sure other professions like med school and stuff like that, you experience the hard work a little bit later on, whereas in aerospace engineering, you tend to take it on as throughout your college career. So it is hard, and I do accept the fact that people have this vision of it, but I don't want people to be discouraged because they're like, oh, rocket science is something I could never achieve, and it's not. It's something that if you put the effort into learning the basics, besides physics and math, it'll pay off in the long run. It's something that you keep having to work towards. There's nobody that is naturally good at these subjects. It just requires a lot of work, so you have to be willing to put in the effort. And if you are, you'll be able to succeed.
Um, it, how would you go about becoming a rocket scientist? What are the key points that you should be focusing on? And like uh, it, as you come from high school to college, is there anything specific that you should be focusing on? Is it
Yeah, so when you're in high school, you'll have a lot of chances to take maths and stuff. Um, Surprisingly, there's a lot of statistics involved after you've done your college degree, not so much within the college degree, but after you've done it. So that class might be helpful as a high schooler. But um, in general, you want to work on your math and physics. It's okay if you don't automatically like realize you're not getting straight A's in physics, because realistically, physics is a hard thing to wrap your brain around. It does require a little bit more effort and energy than other subjects. It doesn't really come intuitively, at least from anybody I've talked to. But having a little bit of background on it will help you in going into college as an aerospace engineer, but it's no means required. You're going to be having to take certain classes given by the university anyways. It will just mean that you'll have to work less hard during your first couple of years if you take the math and physics in high school and have a substantial background in it. But if you don't, that just means you're going to have to spend a lot of time working your first couple of years that some other kids might not in your field. It's by no means an inhibitor that you haven't done X, Y, and Z before you showed up to college. So don't be discouraged if you realize, oh, I haven't taken mathematics, physics, and I really want to do rocket science. But if you are in the position in high school where you still have the chance to take those classes, it'll definitely make your life easier, if anything. So that would be my biggest recommendation. Also, computer science. I think in any degree you go into, a little bit of background in computer science before going to college. Just any language, not any language in particular. For aerospace engineering, you probably will be working mainly in C++ and MATLAB. But any language in particular to get a gist of how coding works would be really beneficial.
Is math a manifest to studying rocket scientist, or is it more like a aid to or do you do a lot of math?
So you're not really past your first year or two. You're not really taking that many math classes particularly. At least it's hard because the U.S. education system works a little bit differently than overseas. My education system has been very much application based. So taking some of the basic concepts and really working on how to apply those to different problems and different situations. Whereas overseas, you'll find that a lot of the education is based on theory and based on proofs and stuff like that. So there's a little bit more classical math understanding required in overseas learning, whereas U.S. learning is very much application based and kind of setting you up for how you're going to have to work in the industry, which is you probably only have like a couple different jobs or smaller focuses that you'll be working on, but the ability to think on your feet and explore different basic options before moving into the deeps of the maths.
No, I get asked this a lot about mathematics, and people don't seem to understand certain concepts. I say it's tough. Your thoughts on that?
Probably the biggest concepts you'll need to know are integrals. Even like not even that complicated of integrals, but integrals, and as far as dynamics go, because like mostly what we work are in theorems that have already been established by scientists a while ago. And so you want an understanding of how integrals work to see how they've gotten to these point and stages, but a lot of it is really memorization because you have these bank of theorems that have already been created that you are accessing and you're using to remodel based on your new application or however you're planning on moving forward in the industry. So you kind of the background in math is so that you understand what's going on rather than creating new math theorems yourself. So it's you'll notice like the people that have a little harder time understanding math and stuff, their first couple of years will be really hard because that's where you're building the foundation of understanding what's going on, and then that's the years that they really struggle. But once they get past that and start to get into your applications classes where you're learning aerodynamics, astrodynamics, and all these different things, that's where they really, you've got this foundation built. And yes, that was hard for some people, or harder for some people, but once that has been built, it's so much easier to go into what you're doing with the aerodynamics and like all the different branches of classes you take after that.
Sure. There are these couple of, I got this a couple of times. What can you possibly do with an aerospace degree? Well, what are the perspectives of the job? What are the perspectives of the job? Where do you head from it?
There are a lot of job opportunities in aerospace engineering. I originally wanted to be an astronomer. I was going into college during the height of the recession. Around 2008 was when I was picking what college I was going to and what degrees I was going into, and that whole process. And so a major thing on my mind was, where could I get a job? And that's what actually led me to aerospace engineering, because there is so much job opportunity within the degree. Now, I don't know if you'll be working in space necessarily within that area, but you will probably, there's so many job opportunities. Now, that's kind of changing a little bit. The landscape with that is changing right now. Although there are many opportunities, some companies are closing doors while others are opening. So I know, like United Launch Alliance is doing under a huge hiring spree right now, whereas Honeywell and Boeing have kind of slowed down. Mm-hmm. It really depends on the particular employer and what they're doing with, like, what their aerospace companies are constantly buying each other and stuff like that. So how that job market works really depends on when you're leaving and what college and stuff. But that isn't something I would really be worried about as far as figuring out if I'll have a job coming out of it, because there's so many different jobs within space and the aeronautical world itself. You probably won't have a problem. You might not get the job you want. It might be a little bit more boring. If you, like, let's say you're really interested in space and rockets, and you have to do work on engines, like regular plane engines, that might have to happen, but you can easily build your way up.
There is this notion that there's this notion that's already put up by, I don't know, a lot of places, that rocket science is hard, and many people don't think of becoming an aerospace engineer because of this misconception. So your final thoughts on that? Your final thoughts on like studying rocket science?
Yeah, when you take your physics classes, I say this in a couple answers on my personal blog, but I don't want you to approach the class so much as, am I good at this? Because that's a really tricky slope, because you have, it's hard to be naturally good at physics. What I want you to look at when you take these like physics or math classes is, can I do something within this? Do I find any of this interesting to me? And that's what I want you to make your decision on. Because if you have some sort of interest in the area, or not so much in like space, but in what you will be doing in space, which is an important distinction I should make, is that you will be doing a lot of physics and math. And if you don't enjoy those parts of your job, you could be weighed down and not very interested and not wanting to work towards it. So there has to be some sort of interest in that, or ability to see past what you're doing towards the application. But if you're interested in what you're doing, that's the key to being successful in this industry. And
so I wish to add on to your point that you need to be very passionate about what you do. And I get this asked a lot as well. Like, what does it take to become a successful physics major, or what does it take to become a successful engineer? And I believe that it's to learn to think like a child and be curious about what's happening around, and you need to take in the interest and go ahead with it.
Right.
Um, so we'll get into some technical questions that
Okay.
um, so you interned at you visited the NASA center. So how was it like, and what did you gain out of the experience, and how does one get into NASA for a job?
Into NASA for a job? Okay, so when I went to NASA, I went as a social media affiliate. So I was doing PR basically there. So they were giving us tours and access to certain things like that. That you can go through NASA's social website. They have all sorts of opportunities on there. They recently went to the SpaceX launch. I couldn't go to that, but you can apply for positions there. They'll ask you a couple things like what kind of following you have and ask for references to your website so that they know you're a legitimate person. But that's how you go through the routes to getting access to those tours and an opportunity to meet a lot of different cool, interesting people. As far as working for NASA, there's a couple of outlets that you can do that. NASA has a just website called USA Jobs where they put, or the government has a website called USA Jobs where they post a bunch of positions at NASA. That as far as jobs go at NASA, that's a main way to get them. There's also internships through what's called the NASA Pathways program. That's also how you get those internships is through the USA Jobs website. Another thing NASA has is called OSSI, which is the One-Step Shopping Initiative, where they post all of their internships besides the ones that are in USA Jobs through the Pathways program. Pathways is just like a monetary, like this amount of designated money towards this amount of interns. But as far as any other internship, you can get it through the OSSI website. And that will list all the different centers, all the different projects you could be working on. And that gets due around early February or beginning of March, and you need a couple of recommendations and just fill out their main form and then apply to jobs through there. The cool thing about that website is that it's not just limited to people in college that are trying to get an internship. It also extends to high schoolers. Mm-hmm. And the last way to get a job at NASA, or at least an internship job at NASA, is if you want to work at NASA's JPL, Jet Propulsion Laboratory. They actually have their own website for applying for jobs, so you can apply for an internship through that website instead, or all their different programs are through that website. And I have a link to all that stuff on my blog if you guys are interested. If you can't find it, you can just ask me it again, and I'll post the links too.
What about the medical field in NASA? What kind of people are they looking for space exploration? And
yeah, they have a lot of different. They have a lot of different job positions. Actually, there's been a physician position. I've been kind of stalking the USA Jobs website, but there's been a physician a couple of physician jobs open at NASA. I think Johnson Space Center, for people that are interested in that. There's a lot of research being done by astronautics and like the kind of consequences you have about sending humans to space and what kind of precautions you need to take, and all those studies. A lot of them go through the universities also. So if you're interested in that, there's a lot of programs. I know there's a program at the University of Colorado at Boulder, also the school I will be attending. But there are projects all over. And even SpaceX has their own group of bioastronautics that are working to design their spacesuits. And so all these different companies have their own representatives for the medical field.
Talking about SpaceX, this question was very interesting. Why is SpaceX turning to reusable rockets when NASA, decided to ditch this idea a couple of years back? I think somewhere around 2011.
Right. So they didn't really get the funding for it, and probably the main reason is that this is all very much risk analysis. It costs money to send the rocket back. Like you have to you have to add excess fuel and excess fuel to have the rocket come back and land on the barge. But the idea is if you can salvage the rocket, there has to be some sort of balancing act with how much money you save from reusing the rocket versus how much money you spend on the rocket fuel. And so NASA kind of decided early on that the process of, or NASA with the combination of US government funding, decided early on that that wasn't an investment they were really willing to make because it didn't have a for sure outcome. SpaceX, I guess, decided, hey, it's worth the risk, let's try it. And it's working out really well for them, so power to them. Now, a reason why NASA, after seeing companies like SpaceX invest in this technology, aren't doing it is because, and Blue Origin, I don't want to ignore them too, is because NASA's current launchers, the SLS Space Launch System, is so powerful that it would not be realistic to have a reusable rocket on that rocket. So they did look at it for a second, but only for like a second, because it's just such a powerful rocket that you can't do that with that particular rocket.
Oh, okay. We get into interstellar travel. How close are we to an interstellar travel?
Very far. It's a nice theory, but honestly, that's just not going to happen. The amount of power you'd need to do interstellar travel, and not to mention the fact, probably the most feasible option would be a wormhole opening, but we haven't even seen wormholes to exist. So the idea of having one big enough for a spaceship to go in, that the spaceship won't then make it collapse, because entry of a spaceship, normal matter, or to a dark, the entry of the spaceship would close the wormhole to a black hole anyway. So it's nice to think about it, and it's really cool inside science fiction, the way they have fun with that, but there's no real way to happen. Like, you can't really, it's just too hard. It's not where the technology is anywhere remotely close right now.
Are there any designs being under development, or are there any existing models that are
well, the thing is, like, with the space industry, you kind of have to have a realistic application to everything. You don't want to go into the route of interstellar travel and stuff like that, because everything needs to break down to, hey, can I get funding for this? Well, because somebody's footing the bill for you doing your research. So you need to make it realistic and something that the government or different private entities would be willing to invest in. And if something is as unrealistic as interstellar travel, nobody's going to be willing to watch their money go down the drain. That makes
sense. Why don't spacesuits bulge like the Michelin Man?
Oh yeah, I like that question. The funny thing is that spacesuits actually are already inflated. That's how they remain pressurized. So the reason they're not going to further bulge out is because they've already been pressurized and they already are inflated to what they need to be for astronauts to go out. It's actually a big problem because these inflatable mechanism is harder for astronauts to move around, and mobility is a big issue. So they're already inflated. That's why they don't bulge out more, I guess.
Talking of interstellar travel, do you really think that we should send people to Mars?
Okay.
As a first step, do you really think that we should send people to Mars? I think they want to ask.
The thing is that you can only get so much information by sending unmanned systems or unmanned satellites to systems like Mars and stuff. There's only so much information that we humans can get from that. With things like Microsoft's virtual world they made with Mars's Curiosity rover to try to make it so that humans are virtually there, that adds a little bit, but there's so much more that you can get out of research with actual humans on the ground. So that's the main reason why you see astronauts stepping up and are very excited about this program. See Scott Kelly willing to spend a year on the International Space Station in order to help achieve this is because experiments can only do so much without people. And that's another reason why when astronauts go to space, they spend besides the exercise, food, and sleep, they spend almost every second doing work and doing experiments because their time is just so valuable up there. So definitely I think that astronauts on Mars their time would be precious, and NASA would be saving every minute of it. And that's kind of why it's important, is that you can only do so much, I guess, broken record, but you can only do so much without people to actually carry out experiments.
Okay. How would you go about putting people on Mars? I know it's a very easy thing to say, but how would you go around implementing? Putting a man on the moon took a lot of effort. So
yeah, you mean like, are you saying like, would it be like, because there's a big topic about whether it should be a one-way ticket or a round trip. Is that what you're asking about, or?
I think
how the program would work.
I think it's about how the program would work. The question goes on to say, would you keep the moon as a base station and then move to Mars, or is it more like you have a direct trip towards Mars?
Okay,
I think what they're trying to ask is, how would you go to moon and then go to Mars, or would you just directly aim at the Mars?
Okay, so right now we would be going directly to Mars. That's how NASA's journey to Mars is kind of going. We are going to the moon first, but that's sort of to test out the Space Launch System, make sure everything's working right before we send our astronauts, make sure all the different technologies are working right before we send our astronauts all the way to Mars, where it's months away, and their return trip is not for a while. Right now we aren't launching from Mars, or from the moon, but that is a big topic, especially a lot of the Apollo astronauts really like that topic, as far as launching from the moon, because it is more cost efficient. But the problem is it's more cost effective if you can get fuel from the moon. Like if you have to carry the fuel from Earth to the moon, then you kind of lost the cost effectiveness of carrying it to the moon to Mars. So having a way of mining the moon per se, and using the fuel and water on the moon to make rocket fuel would be very instrumental into launching from the moon and using the moon as a base and making it a lot more cost effective. But that isn't where NASA is particularly spending their research and their money right now. So I think that would be a really cool option as far as my personal interest. But as far as what NASA's planning with their journey to Mars, that is not included. They're planning on launching from the Earth.
Okay. Coming back to your research work on space debris, how did it get there? Where did all these space debris get there in the first place? Is it from these rockets, or did something break off? Or
so space debris comprises of a lot of different things. Ever since Sputnik, we've been putting things in space, and they've just mainly been just leaving them there. So the accumulation of all these different satellites, but also in addition to that, upper rocket stages will be lingering around in space too. So our main studies are about learning about the different parts on the satellite and how those compromise space debris, and how upper stage rockets look in space and how they move around. So yeah, the epidemic has gotten out of hand, and a lot of research, though, or not research, but the way the industry seems to be moving is that they're wanting to understand what's up there now and not necessarily bring it back, but what they want to do is have every satellite that goes up now kind of has to have a return way of returning after its time has been done, because once you have like the space debris problem, then things collide and then it just gets that much worse. If you saw Gravity, you saw how a collision of satellites caused a domino effect. But that's a legitimate concern, because there are, at least in low Earth orbit, there are highly populated areas where a lot of satellites are up there doing research, and a lot of old satellites that are no longer functional are just still roaming around up there because they don't have any return plan. So yeah, that's the major reason why there's so much stuff in there. It's just through so many years of space exploration without concern about inhabiting those orbits and clogging them up, that was never really a concern till the past few years. So now that it is, we're aware of it and we're working towards solving the problem, but it's kind of gotten to a point where things are already colliding.
These space debris, why don't they fall off towards the Earth? Why do they hover in space? And
yeah, so once you're put in orbit, you're put at a set speed, and the way you're moving is kind of at this balancing act with how the gravity is pulling you in. So you're kind of being pulled in, and so you're being accelerated, and that acceleration keeps you up at that orbit. So it's a balancing act between those two, and that's how things stay in orbit. Things like air friction, which you have very small amounts up there, but they can cause satellites to slowly come back to Earth, but not nearly as much as if you were to put something on it, like a mechanism that's designed to cause a high surface area where you would have a lot of air friction. Otherwise, satellites tend to just stay in their same orbit, because as they fall into the Earth, they accelerate, and then that keeps them going around. So they kind of are constantly falling into the Earth and then missing the Earth. That's pretty much how something stays in orbit.
That's pretty much like the ISS.
Yeah, and the ISS does slowly recede, so occasionally they have to put a little bit of booster on it and move it back to its normal orbit, but that's a really massive satellite, so it's not really an indication. It's like a massive scale of what could be happening with some smaller satellites, but that would take a lot of time for these smaller satellites to finally come into the Earth, and nowhere near the amount of time or nowhere near on the time scale that we need them to start depopulating the orbit.
Could you elaborate on the ISS, how it falls all the time but in orbit? I think.
Yeah, so what's happening is, like, as far as keeping things in orbit, is you're kind of falling towards the Earth, but you're falling so fast that you miss it, and you kind of like here's the Earth, and you kind of just like, whoop, and then come around to the side, and you're constantly falling and missing the Earth and going around. It depends on what orbit you are and how fast you have to be moving and stuff, and that's all dependent on where in Earth's orbit you are, because if you are moving too fast in your orbit, you don't, instead of missing Earth, you miss your orbit completely, and you can go all the way out and exit the Earth's grasp. But if you're moving too slow for where you are compared to the center of the Earth, you could be pulled back into Earth. So it's a balancing act from where you are, from the distance from the center of the Earth, and how fast you're moving.
It's a really good explanation. You did mention before that we are able to track all the space debris that is hovering about. So do you have information on every space debris there is?
NASA can track up to about the size of a tennis ball or a baseball, so like about 10 centimeters from their radar. Now, they actually also can track, well, I guess I should talk a little bit more about my undergraduate research, because this has a lot to do with that. So NASA can track up to that size, like a tennis ball or baseball. size debris object from the Earth. The problem is, like the International Space Station can be impacted by something 2 centimeters long, could puncture a window on the space station. So you have this huge gap from like 2 centimeters to 10 centimeters, and even things up to like 2 millimeters can cause some serious damages on smaller satellites. So you have there's a huge gap in what we know is out there and what we can measure and what's actually out there.
Is it because of the speed that these objects are traveling at that they'll make a huge impact on the ISS?
Sorry, can you repeat that?
Is it because of the high speeds that these objects are traveling at that will have a huge impact on the ISS?
Yes. So yeah, these things are traveling at like 7 kilometers per second. So something traveling that fast can puncture like pretty tough satellite stuff. But the thing is, NASA had a way of predicting how satellites would break up. So if things like, so if satellites were impacted, they could figure out generally how things would break up and what kind of, even though they could only track up to certain sizes, how they would look in orbit based on Earth tests of how a satellite would break up. So what I was in charge of, or not in charge of, but worked on with DebrisSat was where we launched a projectile going at 6.8 kilometers per second at a mock satellite made of modern materials to kind of get an idea of how modern materials would break up so that NASA could better predict what debris fields would look like once something was impacted, when something hit a modern satellite. So they use a combination of what they can track from their radar or from the Earth, and also what we know about how space debris behaves. And that's still a growing field. We still have to learn about how different space debris moves and how it breaks up when it gets impacted, and that's all things that NASA is investing in right now.
Another question popped up. There is a bacterium by the name Deinococcus radioduran. It can survive cold, dehydration, vacuum, and acid, and of course radiation. What if we borrow some of its ability to tolerate radiation in space and pass it on to humans? And what are your thoughts on that?
Wait, could you repeat that last bit?
Sorry. What if we borrow some of its ability to tolerate radiation in space and pass it on to humans?
Oh, well, I think that's a cool idea for research. I don't know how much is being done in it because that's kind of a more recent topic that it takes a while for things to actually measure up and for scientists to take the information we've learned on different things like bacteria that we've found that survive in these areas and stuff, and take that information and figure out how we can actually use it. That's all process that takes time in and of itself, rather than actually investing in the technology that we know could probably work. So, I mean, that's definitely something that's cool, and it's a cool idea to work in, but I don't know exactly what stage anything would be on with that.
On a similar question, so somebody also did ask, does bacteria and other microorganisms tag along with astronauts as they traverse to outer space, and what is their behavior?
Yeah, so definitely a main concern is making sure everything we send to space is clean and doesn't have bacteria on it, including humans. I mean, there's only so much you can do because humans are a living, breathing thing. The way that they ensure that astronauts aren't sick when they're sent or have any sort of virus they're bringing on with them to infect other astronauts and stuff like that is that they have a quarantine period astronauts go through for a couple weeks before they actually launch, and they actually have backup astronauts that if they're for some reason look under the weather or don't pass a certain test, they aren't allowed to go to space, and that's when their backup representative would go. So there's a whole period of time where they make sure astronauts are healthy aren't bringing anything up to infect other people. And so that's kind of how they deal with that issue. As far as like sending up objects to space, everybody puts everything in or works with things going to space and clean suits. I mean, if you've seen my post to stay at NASA, the Cygnus was getting packed, and you saw everybody was wearing clean suits and packing that whole satellite. And the thing is, though, that satellite ended up having black mold in it. So they actually had to delay the launch of it from like, I think it was originally scheduled for like March 7th, and it ended up being March 22nd. So things like that happen. But it's a huge concern, and definitely one of the biggest things that NASA and different space agencies keep in mind when they put things into orbit.
Another question has turned up. How do they measure the space? How do they know where the space debris is? Do they send in some sort of signals, or they want to know how space debris?
How does NASA track it?
Yeah. How does NASA track this space debris in space?
Yeah, so I think they use something similar to radar and to use it. I can double check that, but that's how they do it. And then again with prediction models, that's a big part on how we figure out how satellites break up, because we've had three major collisions that have really impacted and made a huge effect on this space debris in orbit, in low Earth orbit. And so a combination of that and a combination of how NASA predicts things will break up.
This is a question from my side. Can we make an artificial moon entirely of, like all these spaces, and put them in one place, make an artificial moon?
Yeah, so, well, you have to be outside the Roche limit, which is like the decision whether things get made into rings or moons. Most of our satellites are actually within the Roche limit, which is pretty interesting, because when people put things into space, they have to make sure they won't be broken up, because there are the tidal forces that would cause like an object to be pulled apart and become a ring. They don't want that happening to a satellite, for it to be pulled apart. So that whole assessment goes into making the materials that go onto a satellite as far as low Earth orbit. There is an orbit that's outside the Roche limit, which I think geostationary orbit is, but that's not a very populated orbit because it's very expensive. The further you send something out, it's more expensive. There are reasons for it being geostationary, like if you want something that's just looking at one area of the Earth, that's the main reason for geostationary orbit. But because it stays in the same station with the rotation of the Earth. The thing is, that's not a very populated orbit, so what I expect that sometime for there to be enough objects up there for them to interact with each other and be able to form a moon. No, because it's expensive to send things there, so people are very picky about sending things to geostationary orbit. And then also it is space debris. The space debris epidemic would have to get really out of hand for something like that to happen.
So when NASA is trying to decide for the pathway, the projectile for a launch, they do take into consideration the space debris that is floating above. And is that right?
And like the International Space Station has made, like, I don't know the statistics for this past year, but the year before, as of August, they had made three movers at least to avoid space debris. And I don't know if you've seen Scott Kelly's Time piece, but Time did a documentary on Scott Kelly for his time and space. So they actually go through, there is a situation where while they were filming where they had a piece of space debris that they didn't have enough time to maneuver out of the way. And so the astronauts had to get into a certain module or had to get into the Soyuz and prepare for an emergency evacuation. So like these things are just constant problems for people, for satellite functioning things going up into space, and for astronauts up there.
Oh, okay. This question, I don't know if it's a question or more like a joke. Why don't we dump all our garbage on the moon, keeping the Earth clean?
It would cost a lot of money to dump all your garbage on the moon. We can barely get the money to send people there, let alone garbage.
This is a funny one.
That's a funny question.
There was okay. When does studying about astrophysics involved a lot of chemistry and about material sciences?
Yeah, probably. Wait, was it astrophysics or aerospace engineering? I was coming at it from aerospace engineering, but what'd you say?
No, they were. I think it's specific to chemistry. Does it involve chemistry? Does it involve
What?
studying chemistry, like astrophysics, astronomy, and?
Okay, astrophysics.
I think rocket science.
It's a lot more physics than I would say chemistry or anything. I think you would probably run into more chemistry within aerospace engineering and materials application of that degree. Mostly astronomy and astrophysics majors will have most of their time. I think they have the normal colleges for any science major, you'll require to take some chemistry. And so I think they have the same requirement. But your main concern will be physics and stuff. If you want to do materials and understand that, I would definitely encourage you more so to look into aerospace engineering. But yeah, and there's different engineerings for material sciences too. So it's a wide spectrum.
Do you believe in extraterrestrials?
Yeah, I don't know if we'll ever be able to communicate with any of them. I think projects like the one just started last year as far as searching for extraterrestrial intelligence are really interesting. And as long as some rich person's willing to spend the money, I'm very excited to see if anything comes out of that. But I don't know. I guess my odds are like not very high on whether we will ever be able to figure out if something is out there, or because it's very tricky because we've only been on this earth and we've only been able to be seen as far as communicating with radio waves and stuff like that for the last century. So like the idea of how old the earth is, and we've only done this for the past century, and who knows how much longer we'll be on here. It's just hard to see that even with the vast amount of alien lives out there, whether we'd be able to find another civilization that will be existing at the time we're looking at it. And whether we would be long enough lasting to be able to communicate with said society. So I don't know. It's cool in theory, but I don't really have high hopes of anything coming out of that. But I definitely am excited to see what comes out of the research as far as just personal interest rather than practical interest.
I'd also like to point out about the Drake's equation, which was put up some years back, which calculates this odds of finding extraterrestrials. And if you're interested,
you're going to put that up?
it is this equation that was put up. It's like an argument is to estimate the number of the possibility of finding extraterrestrial civilizations in the Milky Way galaxy. So,
and the researcher that's been doing in it, the personal billionaire that's investing in this right now, his program is supposed to find if there's any form of intelligence out in the Milky Way galaxy, we should be able to know about them within the next 20 years. I guess, 20 years. So, or no, not 20 years, the late 2020, so like 10 years. Something ridiculous. So if something is out in the Milky Way, get excited, guys, because we'll probably be hearing about them soon.
Okay. this one is much more a general question. What are the resources that you propose, or what are the for studying, high school science, or what did you use? And I think they want to know uh, what are the resources that are available on the internet that one can use to in order to better understand
Aerospace engineering.
aerospace engineering. Yeah.
There's a lot of different websites and different personal contributors and programs. I personally mainly read books and stuff like that for my personal knowledge besides outside of the classroom. And I also took a college class in high school in astronomy because I really wanted to learn about it and stuff. As far as things that you have access to now that I would suggest, there's Phil Plait has a series of PBS that's all about astronomy. That's on a YouTube channel. And then I think Emily Calandrelli has a whole TV series. I think it's on Fox, but I can't remember which exact site they promotes it. It's called Exploration Space that she does. And then there's also different things like SciShow Space on YouTube that has talks specifically about astronomy, astrophysics, and aerospace engineering. I think those are good places to start. And then from there, you can branch out and figure out, see different types of the community and different other websites and different contributors. And then, of course, you can always read my website. Okay, we'll be taking only a couple of questions more, running out of time. But yeah, somebody wants to know how rockets work in the most simplistic way ever possible, and they're wondering whether you could do it. The most simplistic way, and I left a good. It's hard to do it with just my mouth, like just explaining. There's a really good YouTube video. I'll reblog it. I shared a long time ago. I think not a long time ago, maybe a couple months ago. But that explains how rockets go to space. I mean, basically what you're doing is you're burning a bunch of fuel to get something to move in the opposite direction. And if it's moving fast enough, it goes into the correct orbit. It'll stay in orbit because it'll fall at a certain speed in which it misses the Earth just perfectly to stay in the same orbit. So that's basically what's happening is you're just lighting something on fire and hoping and sending it in a direction and hoping it lands in the correct area. And then of course, once things get into a certain orbit, there's additional thrusters and things to send things into the perfect orbit where they will be falling at the correct speed to stay in orbit perfectly. Because the big rocket itself can only do so much.
Okay, this one is, I think, can you see the question that just popped up on your?
In the group chat? I'm not getting any of them, but sorry.
Okay, are there any plans to make a WALL-E for space debris?
A what of space debris?
WALL-E.
Oh, WALL-E.
Yeah.
That will clean up. That's a cute idea. So the main reason, it's actually a really hot topic about bringing things back from space. So a lot of the space debris research is about when we send things to space, having a return flight or understanding how things are moving there currently so that we can do avoidance maneuvers. As far as actually bringing something back from space, that is a really hot button issue because that technology could theoretically be used to bring a functioning satellite back from space. And if some country develops that ability, then they could weaponize it to bring down a major communication satellite for another country's defense system. So that's kind of why people have been like not really investing in returning space debris projects that return space debris from orbit to the Earth. But yeah, so it's, I mean, Wally's so friendly. You kind of want him to be out there, but the governments are just so concerned about this becoming weaponized that they just are very nervous about spending any money in research of that area.
What is the coolest thing about being a rocket scientist?
I think the people you interact with. I mean, I don't personally want to go to the moon or do anything as daredevilish as that. But the idea that I'm like walking amongst, like when I go to these different conferences, I'm talking to astronauts and they're in my field and they're talking to me about different things in the industry. It's just really exciting. It creates a whole level of appreciation. One of my friends is actually working at Blue Origin and his cube mate is a past astronaut. The school I'm going to be going to has a couple astronauts on their faculty. It's just like the types of people in the industry are just so have such cool experiences to learn off of is really what is a really cool part about the industry to me. I mean, I really enjoy the math and physics of it, which is why I'm going into something as true to it as astrodynamics and studying the motion of space debris. But as far as like the cool factor, I would definitely say the different types of people you get to meet through the industry. So.
Okay, this is more like a serious question. Since I've got this a lot, there are a lot of girls who have written and who have expressed their concern of whether they could really become rocket scientists or physicists or engineers. And now, since you have reached your, you've tied it through those times, so you ought to gain some experience out of the. So what do you like to share to all those younger generations of people, especially girls who wish to pursue their careers in the pure sciences, engineering, and
yeah. So my biggest recommendation as far as being a woman in STEM is there are a bunch of different communities willing to talk to you and be able to be a support system. There's mentorships and stuff like that. Because I'm an engineer in aerospace engineering, I became part of Society of Women Engineers, and that was my main support system when going through a group with that was largely male-dominated classes and all the organizations were male-dominated, and it might not seem like a lot, but it was very intimidating to me as someone who was just starting college and saw that went into an organization's meeting, and I was a definite minority. And this goes for other different minorities too, not just women in the field. So I would definitely seek out some sort of mentoring program, even if you aren't planning on staying with that organization for life. It's good to have that in the first couple of years to help you build relationships within the community and have that backup system, so that when you go into what other organizations you're more interested in, like if you're interested in making rocket ships, Society of Women Engineers might not do that, but when you go into that, you have all these different relationships you've built through Society of Women Engineers that can support you in going to whatever you're planning on doing. That was the key for my success. I also went to the conference for that, where I had the opportunity to interview and talk with people that were women that were working for these companies, and I was able to ask them questions that men couldn't really answer for me, like how women treat how certain companies treat women and their comfort levels within the company. And those are all very important. So I really appreciate Society of Women Engineers for giving me that opportunity. The biggest thing you're going to have to face is that because you're a minority, you're going to be people are going to be quicker to criticize you. You're going to be held to a different standard. And this is because a lot of the community will see you and will see your successes and will think, hey, that's because you're a woman. Like, this professor just likes to have, I've been told multiple times that certain professors like women and grade E's are women. There's absolutely no truth to it. I didn't get particularly awesome grades in their classes. I know I'm a study case one, but I mean, there was like no truth to it. These are well-experienced professors. But you're going to have those situations, and you just have to learn to trust in yourself and what you know and how smart you are, and not worry about what other people say, what your peers around you are saying. And I know that's not necessarily fair, but it is what it is. As long as you have faith and know who you are, you don't have to worry about how someone else in your classes values your grade or your internships or your opportunities. So.
Okay. Experience. Experience. There is this quotation I did read a couple of days back. It says, "Experience is what you get when you didn't get what you want." So, yeah. So sometimes times can be hard, and
yeah, and I think this goes for anybody entering the field and stuff. You have to take risks. That's how you're gonna get a job. Like, you have to be willing to put yourself out there. You have to be, even if you're very introverted, you don't have to be extroverted. I'm not saying that, but you have to be willing to put yourself into circumstances where you're going to be interacting with other people, where you're going to be maybe get rejected from certain like research positions and stuff like that. But you need to try, because the one that works will be the one that will get you the internship with the company you want. And then that internship with the company you want will get you the job with the company you want. And so it's a whole step of the whole building process that you have to be aware of, and you're going to have shortfalls and you're going to miss some opportunities. But the one or two that happen to work out will make all the difference and will separate you from the pack. And that's the whole part of wanting to get a job, is you have to separate yourself from everyone else by trying, at least.
I think that will be the last of questions we answer in this Hangout session. And your final thoughts?
Yeah, no, I guess I really want to focus on those kids that are like wanting to do the field, but are just nervous about it. I would just say, try it out, try your physics classes, try your math, and don't really worry so much about how good you are at it, what grades you're getting from it, as much as, are you enjoying spending time on this? Like, could you imagine doing this for the rest of your life? Because if you're doing like a bunch of physics problems, you're like, this is the worst thing. I wish I would be outside, playing outside. Like, I can't stand this. You have to realize that's going to be something that's going to be a big part of your life if you were choosing this field. So if you don't enjoy that, then that's going to be a bigger problem than if you're good at it. That's what I want you to like leave with. Of course, my inbox is always open. If you have any questions, I'm pretty good about answering them. Sometimes I answer them a couple days late, but I'll answer any questions you guys might have through there. And yeah, that's about it.
Thank you so much again for doing this, for the blog, and because it means a lot to all the followers and me that you took your time off your work and decided to give this Hangout session, and really highly appreciate it. I'm pretty sure that all the followers did learn something new out of this experience, and if they'd like to have, I know there are a lot of other questions that went unanswered, and probably
I'll answer them on my website.
I'll redirect those questions to your website, so that your website, her website is missaerospace.com. She also has a Tumblr, so you can check her up. I will be sending all those unanswered questions to her, so that So that's about
Okay.
it, I guess. That's about
Yeah,
it, I
the
guess.
main reason why I do this is because I want to be engaged. I want to read it to as many people as possible, so that to break some of the misconceptions that might be in the industry, and kind of realize it's not as scary and intimidating as you might think. It's a lot not easier per se, but a lot more obtainable than it has the notion of being. So, yeah, if you have any questions, I'm always willing to answer them, and I'll be sure to answer any of the questions I didn't get to today because I have to run soon.
Okay, thank you so much again. That would be it, I guess.
Great.
Great. Okay.